All right, kiddies. This is a quick tutorial on chapter 4.7, optimization. These are all applied problems. So yeah, they're all word problems. Every one of them is sort of different. You're going to have to practice these to master it. But remember, you are using calculus and some sort of a formula. Again, depending on what you're trying to either maximize or minimize. Pay attention. Okay, to the language and what's being given to you. So in this example, okay, I'm doing a couple of the classics. Okay, there's a lot of them in the book, and I'm sure there's a lot of them in WebAssign, although I'm not sure how many I assigned in WebAssign. But let's say that a farmer has 80 feet of fencing, and he's going to build an enclosed area, an enclosed fenced-in area with this fencing, but it's up against an existing wall. So for these kinds of problems, we like to draw what we call free body diagrams. In other words, it's a labeled picture of what's going on in the problem. We have 80 feet of fencing, okay? 80 feet. So if we call the width of this X, then the length is going to be 80 minus 2X. All right, keeping in mind that we don't need any fencing on the side that's being built up against the wall. How should we construct this? In other words, what should the dimensions of this enclosed fenced-in area be in order to maximize the area? Keep in mind the key words here is that we're trying to maximize area. So we know we're going to need an area formula. So here we have just a little picture of what's going on. And I would advise whenever you're doing any of these word problems like this, that you draw a picture, label everything, and pay attention to what it is that you're trying to optimize. Because optimization is going to be either maximizing something or minimizing something. Now, in this case, we're trying to maximize area. So we're going to need an area formula. Area of a rectangle, easy. So area is equal to X, which is the width, times the length, which is 80 minus 2X. Before I show you this, let me just multiply all this out. So I have 80X minus 2X squared. So again, nice and simple. Nice, friendly, simple quadratic. And because optimization is an application of the first derivative, we're going to differentiate that. We're going to find A prime. All right, A prime. So A prime is equal to 80 minus 4X. And we're going to set that equal to 0. Pretty easy to solve. 80 equals 4X, or X is equal to 20. So that gives us one of the dimensions. All we have to do is plug this back into the original drawing that we made to find the other dimension. Okay, so if X is 20, that means that the other dimension is going to be 40. All right, straightforward. So we have the dimensions of this enclosed fenced-in area is going to be a 20 by a 40. And if we actually want to find out what the maximum area is, because in some of the problems in the book, they may not just ask you what the dimensions of the enclosed area is, but they might also ask you what the maximum area actually is. So the maximum area is equal to 20 times 40, which is 800 square feet. Right? Simple, straightforward, classic problem. When I say classic, in almost every textbook, you're going to find a problem like this. Okay. All right. And I'll do one more. There are too many different kinds of these problems in order for me to be able to cover all the kinds that might exist. And also, it's just going to take practice. You need to practice doing these. There's no magic bullet here. So I'm going to put this on pause for a moment and grab another one. Okay, so in this second problem, again, it's another classic problem. And we have two numbers. We'll call them X and Y just for the sake of choosing our favorite variables. Two numbers whose difference is equal to 100. So that means that X minus Y is equal to 100. We want to find the product of those two numbers that will give us a minimum. So we have the product equals X times Y. Now, some of you may not understand this, but if we take, for instance, X minus Y equals 100. Take 110 and 10, whose difference is 100, okay? But 10 times 110 is a pretty big number. It's well over 1,000. So there's going to be two numbers whose difference is 100 and who is going to give us a minimum product. So notice that in this setup here, which I'm going to show you right now, I have two equations, the difference and the product. It's the product that we're trying to find a minimum here, okay? But notice that with P equals X times Y, since we're going to have to differentiate P, we can't differentiate that. Why not? Well, because there's too many variables. So we're going to have to eliminate a variable. How do we do that? Well, we know that Y is equal to X minus 100. And then we're going to substitute that. So I get P is equal to X times X minus 100, which is equal to X squared minus 100X. All right, so too many variables. We can't, this is not calculus of several variables. It's calculus of a single variable. So this is what I've done so far. I've used one equation to eliminate the extra variable, so that when I differentiate the product now, I only have the product equaling a function of X, not of X and Y. So now I can differentiate P prime. P prime should be pretty straightforward here. All right, so P prime is equal to 2X minus 100. I'm going to set that equal to 0. 2X is equal to 100, or X is equal to 50. All right, well, if X is equal to 50, plug this back into the other equation there. if x is equal to 50, then y is equal to negative 50. Okay. Now, some of you, I'm going to show you this. Okay. X is equal to 50. Y is equal to negative 50. And yes, when you take the difference of x minus y, guess what? You get 100, even though one of them is negative. And when you multiply them together, 50 times negative 50, you get something like negative 2,500. A negative number is a minimum. That is the minimum number. Okay, so a little bit of a different twist here, but the same approach, coming up with a model, differentiating instead of the equal to 0, finding both the values. All right, so again, like I said, this is only going to come with practice. My advice would be to also go into YouTube, and there's going to be suggestions in the chapter review documents for YouTube videos. And you can even find some others on your own and watch them. All right, so let me end this.